So let's take this data set 1, 2, 3, 4, 5, and we can find easily that the mean is 3. If we add these up, we're going to get 15. 15 divided by 5 is 3. There's 5 data values. Now, let's find the variance, and let's do that using our process. And so what we're going to do first is subtract the mean from each of these data values. So we'll have minus 2, minus 1, 0, 1, and 2. And then when we square those values, we'll have 4, 1, 0, 1, and 4. And then to find the variance, we would find the sum of the squared deviations from the mean and then divide that by the data set, or size of the data set, the number of data values that there are. So here we're going to have 10 when we add all these up, and then we'll divide that by 5, and so we have 2. So the variance is 2, and the standard deviation is going to be the square root of the variance, which of course will be the square root of 2. So now let's look what happens when we multiply those data values by 2. Just like we did with the line earlier, what happened was the data values spread out by 2. So if we subtract the mean now, the mean is going to be 6 now when we multiply by 2. And that's our first interesting thing that we're noticing here. When we add these up, we're going to get 30, and then divide that by 5, we're going to get 6. And what we notice here is that the mean for this data set is twice the mean for this data set. So the mean for the data set that was 2 times each of the data values is just 2 times the mean for the original data set. Now let's go about the process of finding the variance. So if we subtract 6 everywhere, we're going to have minus 4, minus 2, 0, 2, 4, and then square those, and we're going to have 16, 4, 0, 4, 16. Add these up, and we're going to get 40. So this variance is going to be, again, the sum of the squares of the deviations from the mean divided by the size of the data set. And this time I'm going to put a 2 in here, noting that this is twice what we originally had. And so we have 40 over 5, or 8. Now, let's find the standard deviation. So the standard deviation is going to be the square root of 8, which we can write as 2 times the square root of 2. And that's interesting then. The standard deviation was twice the original standard deviation. So when we multiply each data value by 2, we got a standard deviation that was twice the original standard deviation. So we might write that in the same way that we did here. Sigma, when we multiply each data value by 2, gives us twice the standard deviation of the original data set. Now let's see what happens when we add 2 now. So here we've got our original set x, here's twice x. Now we're going to go twice x plus 2, just like we did with the lines that we graphed. And we noted that all that did was move the data values up. It didn't change the distance between them. So here when we subtract the mean, and the mean will be 8 now, and that's something that's interesting. So the mean, when we multiply by 2 and then add 2, is going to give us twice the mean plus 2. Now, when we do our calculations here, when we take our 2x plus 2 values and then subtract the mean, like we've been doing before, we're going to get minus 4, minus 2, 0, 2, 4. And here's an interesting thing. When we square those values, our squared deviations from the mean are the same. same as they were when all we did was multiply by 2. And that makes sense because we noted earlier that when we added to the original data set, it didn't change the distance between the data values. So the variation between them is not different. So when we do the same, we're going to do the exact same calculations here, and we're going to get the exact same value. So we're going to note then that the standard deviation, when we multiply by something and then add something, is just going to be the same as whatever we multiply by the original standard deviation. So in other words, standard deviation when we go 2x plus 2 is just going to be twice the original standard deviation.